An Improvement to the Times by Joseph Scaliger, Book 1, Chapter 4, of Years. The greatest system of the days is the year, which has many various names. So many years can be constituted with so many erroneous sidereal periods. The solar year is understood to be a faithful circuit, which indeed is two similar circuits, with one from summer solstice to summer solstice, or winter solstice to winter solstice, and is the minor Julian year, or marked by the zodiac returning to the designated zodiac, which is the greater Julian year. That is greater than 365¼ days, from where they are set apart. Almost the same quantities with the Sun are attributed to Venus and Mercury. Saturn's period in days is 10,747, 18/60ths, 59 seconds, 13/3. That is 29 Egyptian years and 162 days. Jupiter's year is 4,330 days, 17 hours and 15 minutes. That is 11 Egyptian years, 315 days. Mars' year is 686 days, 22 hours, 24 minutes. 1 Egyptian year, 321 days. The Moon, 29, 39/60ths, 50 seconds, 8/3 days. Still, generally, as the two celestial markers, the Sun and the Moon glide along the heavens, which guide the year, and is the reason the civil times began. And the Moon's first circuit belongs to the year, among the Egyptians the final three, and among Arcadians it is the same as the Egyptians. At the end of the 12 lunar periods, the civil year constituted 354 days with 3 and a little more than 2/3 hours. There are also 12 signs of the zodiac which also compose the solar year, as we have said. But ignorance of both the sidereal movements and the other forms the ancients conceived, of which the oldest is the year indeed described by the course of the moon, but there is uncertainty in the new moon, because not all can observe the moon. Generally, the accustomed observation was properly civil months which cannot be distinguished. Since then, this mode of uncertain new moons was agreed for the first time. The moon would consist of 30 days exactly. The 360 days a year was constituted, whose kind long described this type of lunar year. For a long time this was the form of the year among the Greeks. In the East there was 72 parts in the year, of which there are 5. The days advance in the Greek year. The year is 365 days, by the rationale of the solar year, at least departing from the judgment. Hence the two most important kinds of year among the ancients were neither lunar nor solar, but an ambiguous blend of both kinds. The prior form still exists in Greece, and the other in the East. In Greece, however, no one way of improvement was put forward. It was difficult to rationally measure all of the full moons to, and also time certain actions of civil work that required the phase of the moon. The Olympiad always celebrated the full moon on the 15th day of the month. But should the 15th of the month fall equally on the 15th of the lunar cycle? This can only be done every 4 years, adding a day twice, which is called anarchos numeros. This 4-year elidensibus cycle was called the Olympiad, Delphi Pythians, whose month was just on the first of the lunars. The rest of the system wavered. First, Cloestrus attempted to reform the lunar type of year, having discovered the octaeteride, the 8-year cycle of 2,922 days, where all other full moons occur. The common year is 354 days and the intercalary 384. The junction is 99 days. The 8-year cycle's fault was detected, as the Metonic 19-year cycle consists of a full 6,940 days. With revisions to the Calippic period, the successive days were 27,759, without any seconds appended. The year from the Metonic edition is 103. A final example also follows from Hipparchus, the 188 years of the Calippic epoch, a period consisting of 111,035 days, which is 1 day less than the Calippic's 5 metonic cycles, where 2 corrections were applied to Greek equal years. The other part is adjoining the interrupted full moons and the void that exists between the Greek year being greater as it was equal with the sun, and the lunar years which was less than the solar. But the other full moons and incomplete months also vary, in both natural and civil. The natural variety commences the start of the intercalary month, on the day. There are but 2 of the months driven by the full moon. For the Jewish year, with intercalary month Adar, then Sheshbar, Adar consists of the intercalary days until the next full moon. In the approach to the last month of the Arabian year, which is said of Dol-Hagathi, with the Hagathi itself preceding Dol-Kathathi, both consisting of 30 days. But in Samaria, often the conjunctions of 30 moons and the antique Jewish month, Harpalus, the Metonic and Calippic, did not always consist of the alternate, but often 2 full moons occurred, but never with a gap of 2 days. And also, with the days approaching the last Arabian month, 3 continuous full moons are full, Dol-Kathathi, Dul-Hagathi, and Muharram, following in the year. It is said the Arabian year, Kabisa, that is the intercalary. So also the Jewish year has 3 full months of continuous full moons, Tisri, Marshevin, and Kaslu. The various civil times were added to the whole Jewish year, increasing the month of Marshevin by 1 day, and Marshevin is excavated to become full. Other intercalary months are in a different place and time. In this example, it might be in the middle, or the final day that is intercalated in the last Attican month of the year, which is called Posidion Proteros. In Judea, the 6th month is intercalated, said to be prior to Adar. In the Hijri year, the intercalary month jumps between them, and traverses all months in the 228th year, which is 12 cycles of the Ennia Decaeteroid, whereby the memory of intercalation by our great-grandfathers was used by the Turk from Kiliki until the Hijri year, which was replaced by the beginning of the simple Muhammad system. But in the ancient Roman year, the position of the intercalary was far more diverse from the others, but never intercalated between 2 months. Another custom of the month, just like a twig being cleaved and maimed. Between the 23rd and the 24th, or between the 22nd and the 23rd of February, it is inserted. And this is not the last reason. Indeed, the beginning is always observed from the following month of March, and is always 28 days after the start of the Tidish February, and at regular intervals between the end of January and the calendar. February is usually the same as Mercadonia, and the 1st of February is no different between a regular or intercalary year as seen today, now during the festival of Regifugium, or the festival of Terminalia. Nor is it always intercalated between Terminalia and Regifugium. The want of Censorius, which in this manner was February, ordinarily thought of now as 28 or 29 days. It is also an error from Varro that convinced him. In time there are different intercalations, and the Jewish never intercalate before Hyperochi Hiliaki, that is 10 days with a little more than 21 hours. It is the reason the solar leads, and the common lunar month can be conflated. The space between is never more than 3 years, and never less than 2. In 19 years, it always happens 7 times. The intercalary makes the Calippic and Metonic years sometimes pass faster and sometimes slower, which is seen as the postulated rationale Hyperochus Heliacus, where this is one caveat especially to the Athenians, not the Hecatomian new moon anticipating the summer solstice in that ancient epoch. With the Jewish year, those many new moons really anticipate Tisri at the autumn equinox. The true new moon of the ancient Nisan is the spring equinox, if the Julian year needed a reason. The lunar year is not just one kind, but the most important division is the two summits dividing the years periodically and singly. The periodic year dictates that certain orbital years occur in intercalary interval. This kind of ancient interval cannot be defined with certainty. Obviously, the days of Cloistris are 2922, Harpalus 2924. Eudoxus was more than 2922, less than 2924. Menton's other, and from all the diverse Callippus, and finally from Hipparchus's departure, whose opinion, somewhat chastised by celestial reasons, the lunar Enea Decaeteride, is shorter than the Julian. Together with a little more than an hour, around 27 moments. The simple year and itself, which is without remedial intercalations, recur in the ancient epoch. But the long interval is 228 Julian years, which is simply 235 Arabic years, a discrepancy of 50 minutes a day. There is also the cavity on the lunar year that is superfluous and uniform. The hollow year is compiled with exaeris himeris, like from our exaerisimion etos, as it's called, for since the days extracted on account of the civil institutions, such as the Jewish year, whose deficient Jewish computers called, in his quip Caslu, which by the nature of full moon institutes the cavity, or from a natural cause, in the 19-year cycle of Dionysius, Passover 1 day is removed, which is called the Solstum moon. However, the Greek computers, Hypotomen Solenis, in spite of keeping the last year in the 19-year cycle, which constituted 353 days, which does not express a natural year, superfluous years, we call for etos hypernumeron. In addition to this numeron embolumos of civil cause, in the Jewish year, Marsheven, there is a natural cavity. The civil is full only from the natural causes. The 11th year of the Arabic 30-year cycle, the lunar year advances by 1 day. The year is equally called etos omalan. The Jewish computers say it is a normal year. It is with nothing added, nothing removed. Until this, there are disputes on how to equally reduce the lunar year. Now there is disputes over the major equinox, which Egyptian, Persian, Armenian, Mexican, and Peruvians used. Here the ancient Oriental nations were one and the same, except that whenever 5 epigomen were transferred to another place, the start of the year consisted of epigomion, traditionally justly used that after 120 regular years of regular full months were intercalated, that Persia, which when their epigomius is always delayed in the vernal equinox. The end of the cycle is called Neures, and has the superficial embolimon. Every month of the year wandering until the first month returns back. So after 1461 pass, it is equivalent to finish 1460 Julian years. Here is a larger year of which months of the year are equally 30. How many days of simple epigomione, but in 5 4-year periods? It has simply 5 extra days. But what is the form of the year they retained? In the cause, it is not so much ignorance due to our solar year, but simple and traceable, which is the true popularity of its use. Otherwise, there were almost no nations ignorant about the quarters of the solar year. But it was unknown the kind that dispensed in excess of months, who are greater than 30 days, and retreated a little, which is necessary to return, as a quarter of it remains. Every 4 years in Egypt, the required intercalary day occurred during the rising of the dog star. And every 4 years it passes through etos ilikon, etos theoi, etos kinikon, as they were called. The Attican day every 4 years intercalates between the 7th and 8th day of January. Elis between the 8th and the 9th of July, Syro-Macedonian, Chaldean, and Judea between the 7th and 8th of October. In that way, intercalary days from Seleucid times extended as far, and under the imperial Constantine he retained the Jewish, which they certainly did at the time with the form of the Calippic year that the victorious Syro-Macedonians accepted. Roman Attica followed on the winter solstice to rely on the intercalary, which itself is called the Olympiad Mysteries. For Attica and all remaining Greeks, the solar years were divided into quarters, Hukentra occurred every 91 days 7.5 hours, being its notable attributes, which is the time of the Seleucids. Even down to our day, the Jews still observe it. Therefore, July 8th is Tropia Therinia. October 7th, Istanimera Oberini. January 7th, Tropica Hiemeria. April 8th, Istamera Ieria. Thus, with the principle Tropis Therinia and Hiemieras, there is no other understanding, along with Peri Istanimerion. That makes sense. This Kentra is called Tekuphoth by the Jews. The Germans, Celts, Saxons intercalate between the 25th and 26th of December, which we call Modranix. The Tartars between the last day of January and the first day of February, on which the fathers ceremoniously called the White Festival, which was honored by white costumes on that day. In short, through the lunar year, or the far different solar, yet with silent observations after 1460 days, one perceived intercalated days remain. For it is not the other Hebrew quarter, their protected Tekufos, unless the fourth part after each quarter rationally extends. And of course, each Tekupha is 91 days 7.5 hours. Therefore, 4 Tekuphon make only 365.25 days. This, however, displeased the quarterly observations of the Greek astronomers, because the cause is quite futile and juvenile, for the solar was greater than the lunar means demanded, and with the exact sidereal motion still not understood. The lunar comparison with the solar elicited reason, and so many opinions on the solar's greater size, the sum of the period of days in the year's period's distribution was abandoned. The Metonic period is 6,940 days. Divided by 19 years leaves the size of the solar Metonic year 365 days, uneasily dividing 15 and 5/19. The Callipic period is 27,759 days. Divided by 76 years leaves the Callipic solar year being 365.25 days, same as our Julian year. The period of Hipparchus was 111,035 days, 304 years. But neglecting therefore 300 parts days subtracted from the quantity of Callipic solar years, the Phaeite Hipparchus solar year was 365 days, 5 hours, 55 minutes, 15 seconds, and 15/19. Removing this quarter leaves 0 hours, 4 minutes, 44 seconds, and 4/19, which was Ptolemy's sediment. Therefore, the opinion of Hipparchus and Ptolemy tell us about the tropical year in the Julian year, or the Callipic 19-part different lunar Enneadecaetorides, and reduce the Julian, which is the true year, according to the Rabbi Ada. While another, Philia Pythagorean's great year was 21,505.5 days per 59 years, which when divided results in 365 solar days. The Oneopides' great year was 21,557, likewise for 59 years, which divided the solar year into 365 days with 2 21/60th part of an extra day. The Harpali octaeteride divided by 8 years equals solar years of 365.5 days. The Democritus year were 29,950.5 per 82 years, which divides the solar year into 365 days, with a 4th and 164 parts of the day. In short, none of the ancients had reasons to regard the solar or the lunar in excruciating detail, and the quotient is often from certain collections of days intrinsically sidereal and rationally congruent, their total days divided by years. How many of their summed days are they able to confirm, able to see their certain solar year qualified definitively? However wise their ever incomprehensible thinking, nevertheless, for the truth is in the neighborhood that was arranged to be entwined. 365 and a quarter, which is the mode of the Julian year, extended exactly 1 day every 4 years. But this year is comparable to the Egyptian solar and equal in comparison with the tropic. The major reason for doubt about the real year's parts, 11 minutes, 6 seconds, 40 thirds of an hour, following the Galilean form, or almost 10 minutes, 48 seconds, as the Alphonsensi teach, neither are the Prutenic tables much different, which confirm the movement of the solar on the vernal equinox is equal to 365 days, 5 hours, 49 minutes, 15 seconds, and 46 thirds. So hence, there grows several kinds of solar years: uniform, the Julian, tropic, that Persian Galilean. Again, the tropical, or uniform, or celestial, whose tropical dimensions are but the parts, the months, equal and used in civil life, that is the kind talked about by the Galileans. The description for the uniform month is all with 30 days, with intercalary days appended, which in a common year of 5 and leap year 6. The celestial tropic, whose segmented parts in nature give tribute to the zodiac. Again, the solar year can be divided equally in the civil and the celestial. The civil, as the Roman Julian, or the Syro-Gregorium of the Greeks and used by the Coptics. Celestial, as Dionysius Ptolemy, Philadelphia. Because also in the 4th cycle, Canis Major rises exactly in the 4th year, from the end of every period and returning back to its start, the same principle as the revolution of the Epochen, as called by the Greeks, have finally gone to ruin, not preserving the true measure of the tropical year. Because the Julian year could not be seen, clearly the 1st January of the 8th part Capricorn, in which Caesar established, on the 21st, which is almost what it is today. But nothing more convenient would serve that epoch in the Enneadecaeteride. In fact, the tropical Enneadecaeteride is 2 hours more than the lunar version. Again, the Julian Enneadecaeteride is larger than the lunar by 1 hour to more than 26. However, when transgressions are committed against all rationale, tropical, Julian, and lunar, whatever reasonable middle ground there is between the two of them, the end of either epoch has not been seen. It happens in the Easter cycle, with having neither understanding of the lunar Enneadecaeteride nor the solar seasonal motion corrected, but rather its form is merely just callippic, so that its position after 300 years requires a 4-year variation. Therefore, to survive their ancient epochs, immense periods were invented, just like the callippic, philiolic, democritic, enneopitic. There are also periods in which all types disappear, and with all its distinguished annual orbits, both sidereal and rational, have rationale, and yet what confides their inception is an unknown opinion not only of both sidereals, but of all aplanon apokatastasin, and their circuits that happen. In this way, Harpalus and Eudoxus thought that their octaeteride for all Anatolis and Dysinus would return to their orbit. Likewise, the same is considered to happen for Aratus in the Metonic Enneadecaeteride. Eudoxus follows him, which in fabricating the spheres for his planetarium and in Aretium showed the harmonizings of the planets' orbits, whose following restoration of both sidereal was necessary for all planetary orbits to return at its running conclusion. The reason all the spheres of Astron is feigned, as narrated in Aristotle's book 11, ton meta ton physica, is what his counsel allows. Therefore, ton phenomenon is the name understood to mean the rising and the setting, ton apollon, but not ton plaveton ketas episemiasis. That is significant to them because the orbits of the moon and the sun return in a metonic Enneadecaeteride, or indeed the Ecliptic as Hipparchus thought it would fit, though others persuaded against, until they saw the measured tropic year, and in this vice the period chastised them. Cicero, which among Macrobius, the 6th year of his immense republic, whom out of many thousands of years simply compose, that in no other way do the orbitals return with all of their wanderings and strayings considered if the same solar eclipse took place at the same time, because eclipses in the cycles of any decaeterides were not rare. And yet these eclipses are arranged not only for the sun and moon, but also 5 are in error in comparison between them when completing all periods, and they return to their same celestial position, sidereal-like, which especially from the beginning to the end and back again. Why are details of observed eclipses written down in the past? That also ecliptic periodis contrived of what's called exeligimus. Their oldest has 6,585 1/3 days, which is 18 Arabic years and 7 synodic months, and occurs every 223 synodic months. Therefore, in the second book of Pliny, it is erroneously written, by either the fault of Pliny or the scribe, the eclipse returns in 222 months. Hipparchus devised another exeligmius of far greater extent, 126,007 days, 4,267 synodic months, 355 Arabic years, 7 synodic months, 344 Julian years, 361 days, which is a tolerable period. But now, from natural causes, truly the eclipse of the daylight set out how in the 19-year lunar and solar cycles result in the moon and the sun being in the same place as the sun of the first week. And additionally, the Mexican period consists of 52 years, which restores to intrisca decanamera, which is very suitable for our hebdomadis. Nor are the other periods greater than the ancient Persians, as Salchodai voiced. There are others, such as the civil and indiction, as other foolish conjectures insist, as the dodecaeteris is natively Chaldean, as Heraclius, Linus, Orpheus, Dionysus, and Magoras, which the period of motion for the 8 spheres composes 360,000 years of the world. That can be arranged as 184,694 years. But by far the prestigious Chinese, who near the 1,594th year of Christ cultivated an amount of 884,773. Banzaiorus was surely in the Japanese period 470 years before the Christian year 1561 and 1562, and he began running with it for the next 20. That revolution eradicates the transgressions and leads to peace for all times that will come. The diverse Christian, Jewish, and Samaritan are silent when it comes to cultivating an opinion on this matter. For example, the Roman lustrum is 5 years. A lifetime is 110. There are computed periods like the Jewish year 6919, which agree with the lunar cycle 364, solar 247, the 13th great Dionysian period. And in all the weekly cycles, how many days of the week are in the solar year? How many periods of Dionysian? How many months in a leap year? How many cycles of the sun? How many lunar cycles in a great Jewish cycle? Therefore it is most elegant and very skillful. This makes his year 5,354, the common Christian year 1594. And at the next autumn's end of the same year, 1595, from where all the Jewish new moons conclude. The period of Dionysian itself from computed annals pertains to the constant 532 years, revealed by the interaction of each of the cycles. Indeed, the true start of the great period occurs in the first cycle of each, belonging to the lunar and the solar methods, and have place just as much in the Julian year, that is, in fact, with exceptions attributed 365 1/4 days. Therefore, the start of the Roman year is the 1st of January, the Constantine year the 1st of September, the Antioch the 1st of October, in Alexandria and Samaria from 4 AD the 1st of September. The true Dionysian period belongs to the method of the Easter new moon, initially taken from the birth of Christ. So it is thought that from the 10th solar cycle in the Julian year and from the new moons is celebrated on the 14th day after the 21st or 22nd of March. So far, from the trivial beginnings to the sum of times increments, Ezumata Chronon is called by the Greeks guiding chronology, and his place can be seen along with all of antiquity. What survives now is piecemeal and incidentally censored, as explained in greater detail in its appropriate place. To therefore return to those years from which similar elements, progress is made for so many different types of years. Of Greek years which are of minor equality, the form of all lunar years propagates as seen. From the Egyptians is major equality, each one solar. Therefore we do not deal with this by confusion and by satire, but by their own, which, what, place, and order. Therefore the 4 books decree the total explanation of the 4 kinds of year. The first is of the minor equitable year. To that end all Greeks use so diverse kinds, which many nations of the earth also do. Politeia. Therefore, that will survive as part of the rest of this book. The second one, the self-gratifying vindication of the lunar year, due to its previous derivations. The third book includes the form of the major equitable year, and idiotatis, the differences. The fourth illustrates the ramifications of that year and its perpetual propagation, truly several of the kinds of solar years and mutations. These are the first parts, which its initial discourse promises chronology of years and times of the civil categories. The other part is its characteristics, which necessarily note the interval of time. We deal with these following things in the third book, like divisions, the computations of the national annals, of which the books uniquely add the works not in footnotes, not as an appendix, but as part of the work. Therefore, whoever uses this characteristic of the times, we are taught by Dionysius of Ephesus, in which the year of the fall of Troy in the Olympiad epoch was not written, with considerations of other ancient ages in the first Olympiad. He said of the occurrence of the Attic year, which 20 peritae numera extended the year. Immediately the smell vanishes from the Attic year, whose year becomes a possibility, for they knew how many 4-year intervals existed. Example, Euphorius or Dionysius and their noble creative characters, whose ambiguous minds in the trivial establish questions on the spring, leads you by the hand. They will therefore at first totally institute our fundamental Julian year, that constructed the many previous thousands of years. The true characteristics of the two are surrendered, the Dionysius lunar cycle, of which it is the 18th year, and the Julian solar cycle, which is now moved to its 7th year. The third kind, where the ratio of the time suffers, the indiction should not be cast off. For those who utilize these characters once instituted, which is constant and a faithful method, find out the exquisitely beautiful rationale of the times. If there is any uncertainty in this 1594th year of Christ, it is who knows how many years passed since his birth. Yet what is 49 years more, or 56 less? It imitates the imperial Greek chronology that is near his and his king's time, and added by saying, the true certain year is not defined. But since the same birth occurred on the 9th of August, the 5th day of the week, it is the characteristics that are certain and undoubted, such as those of the 20 peritae numera of Ephesus. For the 5th day of the week cannot occur on the 9th of August unless it is with the Sunday letter of roughly 49 years ago that occurred in AD 1540, solar cycle 9. And so with these characteristics we continually affirm the year that man was born. and the nearest 9th of August in Julian begins 55 years after his birth. Likewise, utilizing the lunar cycle extended for reproof, the first year of the Olympiad in AD 1400, all the days of the new moons prove that every 304 years it repeats. An example here is the first year of the Olympiad in 2370. These 7 years repeat after number 304. Therefore 7 days are added today to the new moon. Gracious words, the first year cycle of intercalary days was 11, the new moon of March 18. Adding 7 days to the new moon results in the conjunction of the luminaries on the 25th of March in the 4th year of the first Olympiad, or the 15th since the first Olympiad, and looking forward 304 years. But after we pass 150 years, there is a diminishing number of total new moon days, and are often found to be repeating in 304-year cycles for 1700 Christian years, and perhaps more quickly. Since no ancient epoch is more certain than the Olympiad's weak start, however with antiquity compared to the new that is seen, these will be useful characteristics of cycles and indictions, which from a certain place in the remote epoch institutes the start of their times. Therefore the constructed period contains both cycles and the indiction. What happens if we multiply the Dionysius Exegesis period by 15? We get 7,980 years. Thus the period has its exception from the first year turn by each cycle and turn of indictions. This gives us the same end year defined by the ends of both cycle and indictions. But the Christian year commonly settles, a definitive 3267, at the end of each cycle and indictions. Therefore, subtract 3267 from 7980 years. The remaining years before the common Christian epoch is 4713. So that 4714 is the first year of Christ in the common era. It is solar cycle 10, lunar 2, indiction 4. On the first day of January, although the autumn indiction is near the antecedent, but the lunar cycle should have started from the subsequent March. Why is the year, which is erroneously put in the common era at 1594, actually 6307 in this period, which we call the Julian, from which the Julian year can accommodate that form? For that reason, 6307 divided by 28, by 19, by 15 gives this year 6307 in the Julian period, or the common Christian year 1594. Solar cycle 7 on the 1st of January, lunar 18 on the following March, the 7th indiction of Caesar, which preceded the 8th day of October in the preceding year 6306, but for papal purposes the first day of 6307. I will not praise or laud these periods, chronology and astrology, which is, epistemonicus, wishfully disputed. They are unable to give enough praise. Therefore, those Pruenic eclipse tables are wishful thinking. From the Julian period obtain the year 2498, and with a residual all selected from the epoch times of the flood. Example: a lunar eclipse occurred in September of the 446th year of the Olympiad, which in the Julian period is year 4384. Deduct 2408, and 1975 remains. Select the first 1900 of the epoch of the flood after 75. From siloed years we expand. The last month up to September. What remains is a Prutenic method. Those that want all doubt of the rational times throw out ought to make use of this period, without which not one thing can be certain to support in our notation of the times.